everybody, and welcome to this surprise bonus training event leading up to our big Spanning Tree Protocol event this Wednesday. If you're not yet registered, we are doing a Spanning Tree Protocol deep dive coming up Wednesday, April the 28th at 2 p.m. Eastern Daylight Time. And by the way, Eastern Daylight Time, that's GMT -4 if you want to do your conversions. But in that free webcast on Wednesday, we're going to be covering every single topic related to Spanning Tree Protocol on both the CCNA and the CCNP Encore exams. So you want to be here for that. But for now, I wanted to give you a bonus training on EtherChannel because I was kind of going back and forth. I thought, should I include EtherChannel in the Spanning Tree event? By the way, the link to register for that event is on screen. Should I include that or not? It's not really Spanning Tree, but it's sort of kind of almost Spanning Tree. It's tangential to Spanning Tree. So I thought, you know what, I'm just going to hop on early and do a bonus training event covering EtherChannel because I want to make sure you get a deep dive in that as well. So here's the agenda for this brief webcast coming up today. And we're going to begin with just an overview of what EtherChannel is. And we're going to take a look at the protocol that Cisco gives us to dynamically form an EtherChannel. It's called PAGP, the Port Aggregation Protocol, and there's an industry standard, LACP, the Link Aggregation Control Protocol. We'll talk about load balancing and how many people have a false sense of security when it comes to EtherChannel. They think they're doing load balancing, but maybe they're not. We'll check that out today. And then we're going to give you a couple of demos. We're going to do a demo of Layer 2 EtherChannel as well as Layer 3 EtherChannel. And again, if you haven't registered for Wednesday's event, just go to kwtrain.com/STP. But if you're not familiar with me, if you're just joining me for the first time, here's a super quick bio of myself. My name is Kevin Wallace. I've got a couple of CCIEs, one in enterprise infrastructure, one in collaboration. I've been working with Cisco gear for over 3 decades now. Literally, I worked with the very first model of Cisco router that came out, the old Cisco AGS Plus router back around 1989. I've taught courses for Cisco Learning Partners. I did that for about 14 years. I've been a network designer down at Walt Disney World in Florida, written a bunch of books, done a lot of videos for the folks over at Cisco Press. I've spoken at Cisco Live a couple of times and was honored to get the Distinguished Speaker Award both times. Bottom line is, I am passionate about this stuff, and I cannot wait to spend some time with you today and a lot more time on Wednesday as we cover some of these topics to get you ready for the Spanning Tree area of your CCNA and your CCNP Encore exam. But let's begin with a look at what is Spanning Tree? What's it do for us? Or rather, we'll talk about that on Wednesday. Today, what is EtherChannel and what does it do for us? Well, with Spanning Tree, if I had a couple of links between these two switches on screen as an example, then I would have one of those ports blocking. We would not be sending traffic over one of those ports. One link, the link on the right here, it's just kind of standing by waiting for the other link to fail. However, if I formed an ether channel between these two links, then I can send traffic simultaneously across both of those links. And that's going to give me some advantages. It's going to give me higher bandwidth between switches because I don't have one link that's just on standby waiting for the other to fail. We're actively using these two links. Oh, and by the way, I'm just showing you two links as an example. But with EtherChannel, you can set up an EtherChannel with 2 links, 4 links, or a maximum of 8 links. And this is going to give us load balancing between those links, and it's going to give us redundancy. You might worry that if we're not using Spanning Tree to block one of those paths, have we lost redundancy? And the good news is no, we haven't. In fact, if we lose one link in a channel, the remaining links continue to work. So it gives us more throughput, load balancing, it gives us redundancy, and there are a few different ways of setting this up. Cisco gives us a protocol called PAGP, the Port Aggregation Protocol, and that's going to dynamically set up an ether channel, perhaps by us just configuring one end of that ether channel. The industry standard, LACP, does a very similar thing. We'll talk about the difference between those coming up. In fact, let me tell you the big difference right now. I said that we could have a maximum of 8 links in an ether channel. That's true for both the PAGP and the LACP implementations, but With LACP, you've got an additional option of having 8 additional links on standby. Remember I said if we lost a link, the other links would continue to function, but obviously you lost a little bit of bandwidth. But with LACP, there's a way to configure an additional 8 ports that are on standby that can start to fill in if you lose any of your individual links in the primary Ether channel. And when we talk about load balancing, there's a lot of misconception about this. And a lot of people have a false sense of security. For example, let's say that we've got some PCs connected off of switch A that want to go to the servers connected off of switch B. And we've got these 4 links formed in an Ether channel. That oval symbol on top of the links, that indicates that they're bundled together. Well, the way this is going to work is we're going to look at, in fact, here's the way it's not going to work. A lot of people just assume that the first packet goes over the first link, the next packet goes over the next link, and on and on. That's not the way it works at all. It's a very mathematical decision. Let's think binary for a second. If I have 4 links, how many binary bits does it take to represent 4 different options? 2. I could have 0, 0. I could have 0, 1. I could have 1, 0. And I could have 1, 1. So when we're deciding how we're going to select the link to go from switch A over to switch B, there are different options, but here's an option that I've seen by default on a bunch of Cisco Ethernet switches, and that is to do it based on the destination MAC address. So we've got these 3 servers, and I'm just putting the very last hex digit on screen. I didn't write out the entire hex MAC address for each server, but the MAC address ends in a 1 for the first server. It ends in a 5 for the next server. It ends in a hexadecimal D for the next server. Those look different, don't they? We're going to be load balancing. Actually, we're not. Here's what I mean. If we look at the last 2, the rightmost binary bits, which is all we're considering for this Ether channel path selection, they're all the same. They all end in 0, 1. That means no matter which server we're going to, we're just going to be using one of those 4 links. Yikes. A lot of people have a false sense of security about that. So what can we do? What other options do we have? Well, we can select different load balancing algorithms. And I'll tell you what I prefer, but I'm listing for you on screen some of the different options available. I like to mix up, just to add some randomness to it, I like to mix up source and destination information. And I don't care if it's MAC address or IP address information. I want to randomize it a bit by including both source and destination. So I might select something like source destination IP or source destination MAC. In a case like that, if I'm including the source in this decision, then I'm going to take the last bit of my MAC address of the source computer PC1 and the last bit of my destination computer or the server out there off of switch B. And if they're the same, I'm going to do an exclusive OR. If they're the same, that gives me a binary 0. If they're different, it gives me a binary 1. So we perform that XOR, that exclusive OR operation. Now, here's the way that works. We're saying that we'll give you a value of 1 exclusively if the values are different. So 0, 0, you do an exclusive OR on those, you would result in a 0. 1, 1, exclusive OR operation says, nope, they're the same, you get a 0. But if they're different, if it's either 1, 0 or 0, 1, then your exclusive OR says, oh yeah, they're different. So it'll give you a binary 1. That's the way I prefer to do it because it gives me more load balancing between those. Now, let's talk about these 2 different protocols and the way they can help dynamically bring up a link. First of all, let me point out that there is a way to set up EtherChannel without doing PAG-P or LACP, and it's called LAG, L-A-G, link aggregation. And that's probably what you're going to be doing if you're working with a wireless LAN controller with a bunch of ports on it. In a Cisco wireless network using autonomous access points, those access points, they go into an Ethernet switch, and the traffic has to go from an access point up to the controller, back down to the switch, out to its destination. So that could become a bottleneck between the Ethernet switch and your wireless LAN controller. Fortunately, Cisco typically gives us a bunch of ports on that wireless LAN controller where we can have a channel, a bundle, like an Ether channel, between the switch and the controller. But most of the controllers do not support PAG-P or LACP. They just support lag, which is basically saying be on. Now, if we're set to on one side, we have to be set to on the other side. Now, auto and desirable, those are dynamic ways of bringing this up. If one side of your ether channel, if those ports are set to dynamic auto, auto means they're willing to form a channel, but they're not going to initiate the formation of a channel. If somebody suggests to them, hey, let's form a channel, they'll say, sure, let's do it, and they'll come up. But they're not going to initiate it. So if both sides are auto, nobody's going to start the conversation. Nobody, it's like a middle school dance. Nobody's going to walk across the floor and say, hey, do you want to dance? No, they're just going to sit there willing to become a channel, but nobody's going to initiate it. Now, if one side is desirable and the other side is auto, the desirable side will send a PAGP frame saying, hey, do you want to be an ether channel? And the auto side will say, sure. Or if that other side is desirable, it'll say, sure, let's do that. But those are the options for bringing up an ether channel. Both sides can be on, or one side can be desirable and one side could be auto, or both sides could be desirable. Now, it works almost identically with LACP, except the names are different. Instead of auto and desirable, we have passive and active. Just different names meaning basically the same thing. So when you set this up, and I'm going to show you that in the live interface in just a moment, when you set this up, you're going to specify, or you can specify how you want that negotiation to happen. And I'll probably just use, I don't know, I might use a couple just to illustrate it. But what I want to do now is to go out to a live interface, and I'll show you the topology that we're working with. We've got 3 switches in this topology, and we're going to be focused on interconnecting switch 2 and switch 3 down at the bottom. Notice we've got a couple of fast Ethernet ports between them, and these are physical switches that I have in my lab topology. And I want to show you how to set up, first of all, a layer 2 ether channel. Now, if I have a layer 2 connection between switches, it's oftentimes a good idea to have that configured as a trunk connection. Remember that a trunk has the unique ability to send traffic for multiple VLANs. So I can do that over a trunk. What better place to have a trunk than a big fat bandwidth pipe that I get by creating my ether channel? So I want to set up an ether channel, and then I want to say, I want you to be a trunk. That's going to give us what is going to appear to be a 200 megabit per second trunk, because I've got these 2 individual 100 meg links. Here's how we do it. Let's go into global configuration mode on switch SW2, and I'm going to configure both fast Ethernet 0/1 and 0/2 at the same time. So I'm going to go into interface range configuration mode for fast Ethernet 0/1-2. Now, notice I'm in interface range config. Every command I type will now apply to both of those ports. And at each end of an ether channel, the port settings need to match. They need to be twins, basically. So what I like to do is to set the speed to auto on both sides. I'll set the duplex to auto. It's certainly not going to work if one side's 10 and one side's 100. And if I'm connecting these with straight through cables, I hope my switch is capable of recognizing that it needs to flip the transmit and receive leads on the RJ45 connector. And I can make that happen automatically by saying MDIX auto. And now I want to create, out of thin air, I want to create that ether channel. It's going to be a channel group, and it's going to be labeled as port 1. Here's how we do that. We say channel-group, and I'll give it the identifier of 1, and I'll say I want the mode to be, now here we see those different modes. If I just wanted to set up lag with maybe a wireless LAN controller, I could say the mode was on. Or if I'm using the Cisco PAGP, I could say auto or desirable, or LACP, I could say active or passive. I'm going to do desirable. I'll say mode is desirable. And it's going to create, there it is, port channel 1, abbreviated PO1, just got created. Awesome. Now, let's set up a trunk over that virtual port that just came up. Here's how we do that. I'm going to say switch port trunk encapsulation .1Q, because if you leave trunk encapsulation negotiation to auto, It may negotiate an ISL trunk. We typically don't use those these days. It's got a huge header, like 30 bytes, 26 bytes of header and 4 bytes of checksum. It's massive. We don't want that. So we'll just stay with .1Q, the industry standard, and I'll say I want to set the switch port mode to trunk. And let's set up the other side. I'll do this quickly. I'll just give a mirror configuration. I'll say interface range, fast Ethernet 0/1-2, speed auto, duplex auto, MDIX, media dependent interface crossover is what that stands for, by the way. MDIX auto, channel group 1, mode desirable. Let's make it a trunk. I'll say switch port trunk encapsulation .1Q, and switch port mode is trunk. I'm saying be a trunk. Now let's give it a few moments to sort of stabilize here, and we'll see if we've got a good connection between these two switches. Let's give some verification commands. And also let's see how we can adjust that load balancing algorithm. First, I want to see, do I have a trunk that's up and active? Let's do a show interfaces trunk command, and I do. It says we are currently trunking. Awesome. And our encapsulation is .1Q. Fantastic. Is my ether channel up and active? Well, it is, because I see my port channel group of 1 right there, but I can get more information. I can say show ether channel to get some basic information. And it says we are a layer 2 ether channel. We're going to change that in a few moments to a layer 3 ether channel. We can have a maximum, as we were talking about, of 8 ports. Currently I have 2 ports, and I'm using PAG-P for the negotiation of this channel. How's my load balancing working? I can say show ether channel load -balance, and I didn't set it. Look at the default, the source MAC. That was a caution I gave you in our slides a moment ago, how that could give us a false sense of security. So let's do this. On both sides, let's set a different load balancing algorithm. I'm going to say port channel load balance, and here are our options. And let's add some randomness by including both source and destination. I'll say source destination IP. All right, let's do the same thing on the other side. We'll say port channel load balance source destination IP. If I say show ether channel detail, that gives us probably more detail than we want, but it's very comprehensive. We're a layer 2 ether channel, currently using 2 ports. We're using PAG-P. If we scroll down to the bottom, it will show us the ports in our ether channel. And here they are. Those are the 2 ports in our ether channel. Now that's a layer 2 ether channel. However, the particular models of switches I'm using 3560s. They're capable of being multi-layer switches. I can turn on IP routing. I can run a routing protocol on these. So let's take a look, based on the exam blueprints, especially of the Encore exam, let's take a look at how to set up a layer 3 ether channel. To do that, I'm going to go into interface range configuration mode again. I'll say interface range for fast Ethernet 0/1-2. And I'm going to turn this into a routed port, or these 2 ports, I'll turn them into routed ports. The way we magically transform them from a switch port to a routed port is by saying, no switch port. And that makes them a routed port. Now I'm going to go into my virtual interface that got created, my port channel interface of 1. And I'll say no switch port, because I want it to be a routed port as well. And in that virtual port channel interface, I'm going to set an IP address. I'll say you've got an IP address of 10.1.1.1, and we're just linking between 2 switches. So I'll say the subnet mask is a 30-bit subnet mask, 255.255.255.252. And let's create a loopback interface. So we'll have a network to route over to switch 3 so we can see it in our IP routing table. Let's create interface loopback 0. I don't have to say no shutdown because loopback interfaces are administratively up by default. And I'll give it a IP address of all ones with a 32-bit subnet mask. 1.1.1.1, 255.255.255.255. And let's turn on IP routing. I'll say IP routing, and I'll set up a routing protocol. We'll say router OSPF process ID 1, and to say that I want all of my active interfaces to participate in OSPF, in other words, I want them to advertise their networks via OSPF, I can give this command as a shortcut. Network is 0.0.0.0 with a wildcard mask of all 255s. That includes all possible IP addresses, so if I have an interface that's up that has an IP address, it falls in that address space, and therefore it's going to be considered routable. And I'm going to put everything in area 0. And we're done on switch 2. Let's go over to switch 3. And actually, I want to do one more thing on switch 2. Let me go back into interface range configuration mode again for those 2 ports. I also want to say channel group 1. I'm going to set the mode to on. Let's mix it up a little bit. And let's give a similar configuration over on switch 3. We'll go into interface range for fast Ethernet 0/1-2. Let's make them into routed ports by saying no switch port. Let's go into interface port channel 1, and let's make it into a routed port by saying no switch port. Let's go add an IP address to this virtual interface. IP address, I'll make this one 10.1.1.2, again with a 30-bit subnet mask. The only other usable IP address in that subnet I created. Let's put a loopback interface on this switch as well with an IP address of 2.2.2.2 with a 32-bit subnet mask. Let's see. Oh, I got carried away with my 255s there. There we go. And I'll say IP routing. I'll set up our routing protocol. By the way, process IDs do not have to match between routers. If we were doing this with EIGRP, that number would not be a process ID. It would be an autonomous system number. They would have to match, just as a side note. And I'll say network 0.0.0.0, wildcard mask of all 255s. And you belong to area 0, I'll say. Oh, and back into interface range configuration mode again. For fast Ethernet 0/1-2, I wanted to say channel group 1 mode on. All right, I think we're done. And it might take a moment for our OSPF adjacency to form. Oh, not long though. It says we have a full adjacency. So if I say show IP OSPF neighbor, look at that. I've got a neighbor over on switch 2. If I say show IP route, you can see that I have learned this 1.1.1.1 network from my neighbor. Awesome. If I go to my neighbor, have I learned about 2.2.2.2? Show IP route? Yes, I have. Excellent. And if I do a show EtherChannel this time, before it said we were layer 2, now it says we are layer 3. So that is a look at how to set up EtherChannel. Now, again, I wanted to hop on here and show you the EtherChannel configuration because I almost included it in Wednesday's session, which is going to be on spanning tree protocol. It's going to be a deep dive, but then I thought, EtherChannel, it's not really spanning tree, but it kind of sort of is. I said earlier it was tangential to spanning tree. So I hope you enjoyed this really quick little demo because I wanted to make sure you got this content as well. And if you've not signed up yet, again, you want to go to kwtrain.com/STP and just register for free for this webcast coming up on Wednesday, 2 p.m. Eastern Daylight Time. Eastern Daylight Time is GMT -4, and we're going to cover every single topic in the blueprint for CCNA and the CCNP Encore exam related to spanning tree protocol. We're going to get into things like, well, we'll certainly do plenty of exercises with identifying port states. We'll say, who is the root bridge? Who are the designated ports? Who are the root ports? Who are the blocking or the non-designated ports? We'll show you how to set up PVST or PVST plus. We'll talk about MST. We'll set that up. We'll set up rapid PVST plus. We'll talk about port channel, BPDU guard, lots of other things like that. And I bet you'll learn something, because we're going to cover probably more than you need to know for those two exams. I want to give you a very, very comprehensive coverage of Spanning Tree Protocol. So again, be sure and join us for our webcast on Wednesday. Cannot wait to spend time with you then. Thanks, everyone. Look forward to seeing you on Wednesday.